add link. I'm going to click on that, left click on that. It changes my cursor to a crosshair. It doesn't matter what you click first. If you click R1 first, ISP, it doesn't matter. You're going to left click a device, and it will show what available interfaces you have to plug into. So this is just like if you were taking an Ethernet cable and plugging it into one of these interfaces. So fast Ethernet 00, need a line here, is connected to the ISP fast Ethernet 00. I believe, if I'm not mistaken. All right? It says 01. Okay, great, no problem. Here's what I do. Thank you for that. I right click on it and I click delete. I go back to the line, or the cable. I'll go 00, 01. There we go, status quo. R1, 01 is connected to the switch, and it doesn't really matter. I think this goes to 10. And when you put it on 10.
Yep.
Do not put it on 00 or 01. Do not put it on 00 or 01. It's got to go onto this switch port module. R2's 00 connects to 11. And R3's 00 connects to 12. Alright. And last but not least, R2 and R3's 01 connects to their switches 10 port. Alright. And I come over here and I disable that and I'm back to my pointer. Alright. So there's everything's cable. Still, have not turned anything on yet.
So why can't you hook it up to the 01?
To 01 because I wanted to put it on a switch port, not a routed port. That's why I made those switches. That's very important. Alright. You have a couple of other nice little handy dandy tools in GNS3 that I actually really like. Okay? For example, if you look at your lab on that topology diagram, it's really nicely all laid out. I can actually come up here to the square, the ellipse. I can create an ellipse. Alright, I can move it around. Oh, shoot. There we go. I can move it around and make it look like what I had there in okay. But when I do that, look, I lost the visibility of all my lines. Don't sweat it. Right click inside the ellipse, and all you gotta do is say lower one level. And then I'll come back. Alright, from here, I can also go up to my add a note. And I can add a note, just like in what you see in your topology. Area 0. Alright? Look familiar? I can do that with the EIGRP and the OSCF area 1 as well. Don't do that for area 1 real quick. Small. Right click, lower the level. I'll make a note over here. I can put IP addressing up here, I can do all kinds of other crazy stuff. Alright, or I can just reference back to the topology. That's just to help you keep your mind kind of straight, if you will. Okay? Alright, so once you're at a point where you're comfortable, you got enough notes down, you're ready to turn everything on. Alright, you can go around to each individual machine and click start. Or if you feel like living dangerously, you can just come up here and click start, and it'll start everything up at once. I'm only doing this because I did it last night and it didn't crash the point machine. Alright, so from here, it doesn't really matter where you start, but the first step that you should do is make sure that your host names are right on everything, and make sure that you add your IP addressing everywhere. Now, switch 1 does not have an IP address, so you don't have to worry about that. You don't have to do anything else to switch 1 at all. Okay, at all. Switch 2 and switch 3, you'll notice that switch 2 is, I think, VLAN 20. VLAN right there, it's kind of a little small to read. Alright. So it doesn't matter which direction you want to go in, top, down, bottom, up, start in the middle, work your way out. You're using basically like a greenfield implementation. Anyway, so I'm going to start from the switches. These two switches, I'm going to incorporate their VLANs, VLAN 20 and VLAN 30, and give them their IP address, and I'm going to work up to the ISP. Why? Because I did it the exact opposite way yesterday in the other class. So, I right click, and I go to console. It goes to console. It pops up, it has its host name there already, don't have to worry about that. It's in privileged exec mode, you're ready to roll. So, type in packet tracer, comp T, alright. If I want to look at the running configuration, I can do a show run, or I can just show run from the onset. Alright. My fast Ethernet interfaces, which is 1.0, which is connected to R2. Alright, is on VLAN 1. Why do I know it's on VLAN 1? Because it has no other config there. I have VLAN 1 here, it has no IP address, and it's shut down. But I need to make VLAN 20. So, let's see if I can do this in this version. So from global configuration mode, I'm just going to type in VLAN 20. Oh, it doesn't like that. Okay, no problem. I'm going to exit out. There's another, in older versions of switches, you actually have to go into the VLAN database. Okay? So you do that by, instead of doing comp T, you do VLAN space data. VLAN space data. I'll write that down real quick. VLAN space data. Right? Now, you can exit out, go back into global configuration mode, and you can create an interface VLAN 20. And VLAN 20. It's not there in the show run until you do that command. Once you do that command, it adds it to the running configuration. From here, you can add the IP address. What's the IP address for VLAN 20 was 192.168.5. 192.168.50. Thank you. I knew it was a 5 there somewhere. 50.2. IP add 192.168.50.2. It's a class C subnet mask. No shut. And then I can look at the show run. Do show run. see? VLAN 20. All right, now the interface that is connected to R2, which is Fast Ethernet 1/0. I need to make it a switch port. I need to add it, actually there's already a switch port. I need to add it to VLAN 20. Okay, so how do I do that? Int F1/0, switch port, access, VLAN 20. Switch port, access, VLAN 20. Enter. We can also do switch port, mode, access. I really wanted to get crazy. I'll let the show run again.
Was that last command?
You don't have to do it. It's already a switch port. Switch 2, we're going to do the same thing on switch 3. It's just the IP is going to change, the VLAN is going to change. Same concept. So let's go over to switch 3. Right click, console. Host name's already done. All right, actually, oops. From privilege exec mode. VLAN data. That goes in. That makes you go into your VLAN database, and then you just have to tell it to create VLAN 30 by typing VLAN space 30. And it does. Exit out of there. Little configuration mode. I'm going to create interface VLAN 30. Int VLAN 30. I'm going to give it its IP address. IP add 172.21.0.2. Class C. This is from the lab. Look it up there. And no shut it. Okay. Done. Now I go into the interface that is connected to R3, which is Fast Ethernet 1.0, same as on switch number 2. Int F1/0. And I put in switch port, access, VLAN 30. So that it is on VLAN 30. I get a little message that VLAN 30 comes up. I should. Anytime now. There it is. Take a second. All right. So, for all intents and purposes, these two switches are done. Okay, they're done. There's one other thing that you can do on them for testing purposes.
Are we supposed to be writing the confirmation?
Sorry.
Are we supposed to be writing the big?
Yeah, write early, write often, so you don't lose power or whatever. You can do that at any time. To write configuration, it's the command WR. So here, I'm going to switch back to switch 2. From privilege exec mode, WR, that's it. Okay. You can do write mem, you can do copy run start, it does the same thing. WR does the same thing. Shortcut, because I'm a lazy network engineer. All right. So the other thing that is kind of important for each of these switches is to tell them where their default gateway is. So from global configuration, IP, default, gateway, and then the IP address of the upstream router. So on switch 2, it'll be 192.168.50.1, and on switch 3, it'll be 172.20.0.1.
So why are we using that command here instead of the IP
Because
route?
it's a switch, not a router. It's a switch, not a router.
There it is.
All right. Now, yeah, it's a layer 3 switch. I could put a default route there. I don't want you to, because I want you to treat this as a switch. That's an excellent question, though. All right. So default gateway, Done. Write that back to memory. We'll go back over to switch 3, do the same thing, but on the other subnet. Write it to memory, and now those switches are completely done. So I don't even have to do, I can close the console. All right. From here, I'm just going to keep moving up. I'm going to do R2 and R3. Now in step 6, notice that it tells you to change the subnet mask from the original topology from a /25 to a /29. Alright, now if you put a /25 in there first and you go back and you do the /29 later, that's fine. Just make sure you make it a /29 at some point in time. I'm just going to skip to the chase and put the correct IP address in there from the word go. This is on the OSPF Area 0 interface. So I'm going to console into R2. Alright, I'm going to go into interface F00. Do IP add 201.68.109.130, which is its IP address, and /29 subnet mask. What's the last octet of a /29 subnet mask? To what? 248. Remember to turn the interfaces on, no shut. Okay? And then I need to go into Fast Ethernet 01 and put the IP address for the 192 network. Again, I need to turn the interface on. Okay, that will come up. Come on, anytime now. Why are you not coming up? Okay. Yeah, I did put .1. That's right. 50.1. Okay, on the router, I'm not on the switch. 50.2 is the switch, but it's not coming up. So let me just do a quick test. Let me ping myself. I can. I only ping switch 1, which is .2. That's not good. I know what the answer is, guys. I'm kind of leading you on here. Go back to switch 2. I'm ping myself, but I can't ping .1.
There's not the same.
I'm sorry?
They're not on the same subnet?
Did I goof that up?
No, I'm just wondering.
No? Easy way to look. She'll run. Nope, it's class C. Look at this right here. This will throw stuff off on these switch port modules a lot of times. They've got to match up. They can't be auto and auto on both sides. I tell everybody to make sure the speed is 100 and the duplex is full. Oh, I know what I did wrong. I am dumb. I put the IP address in the wrong interface. Int F00 201.68.109.130. I didn't change interfaces here. Int F0/1. There we go. There we go. That's what I'm looking for. Now I can go back and ping 50.2. key here is one side can be speed auto, duplex auto, but the other side has to be configured. So I have the sides configured for the switch, which automatically came up. The other side doesn't matter. You have them matched. Okay, you can't have one half and 10, the other full and 100. That'll cause it to crash. You can't have both sides auto, they'll never figure it out. You can't have both sides full 100. Alright, so now I have connectivity between R2 and switch 2. We go back to we'll go to R3 now.
So you did change the speed on that?
No, I didn't. I didn't have to.
Okay.
What I did initially is I put the wrong IP address on the wrong interface.
Okay.
So int F00, which faces the WAN, the OSPF network, its IP address is 201.68.109.148. Turn it on. And the inside interface, the interface facing switch 3 is int F01. Its IP address is 172.21.0.1 class C. And turn it on. The no shut command. Okay, it comes up, your test, ping yourself. 172.21.0.1, and then the switch 0.2. There you go. And now you should also be able to ping R2, which is 201.68.109.130. Go. So I now have connectivity between router 2 and its switch, router 3 and its switch, and between R2 and R3. Alright, moving up the chain. I'm just doing IP addressing here, guys. I haven't even gotten to routing yet. Going to R1. Now its F00 faces its ISP. And F00. IP address is 201.68.109.98. Does that sound right? Look on the live real quick. It's .98. 96.
98.
98, yeah. And that's a /30. What's the last octet of /30? Correct. Turn it on. And then the inside interface, fast Ethernet 01, its IP address is 201.68.109.129/29. Turn it on. Alright. Now I should be able to ping R2 and R3. Ping myself first, then R2, and then R3. Cool. So now I'm done with the IP addressing of R1. So R1 can ping R2, R1 can ping R3, R2 can ping its switch, R3 can ping its switch. One last thing I want to do, I'm going to go to the ISP router and just put the IP address right here. Alright. Oh, I don't have a host name there. Gotta fix that. Host name, don't forget this, ISP. And then it's interface. If you forget which interface you connected to, you can always go back here and just hold your cursor over, and it'll tell you what's connected to what. So fast Ethernet 01 is connected to R1, so I go to fast Ethernet 01. ISP, int F0/1. 1, IP add 201.68.109.97. Slash 30. No shut, turn it on. Wait for the Ethernet interface to come up, it does. Ping R1, which is 98. There we go. So now, the ISP can ping R1. R1 can ping R2 and R3. R2 can ping R1, R3, and its switch. R3 can ping R1, R2, and its switch. Alright, true or false? I went onto the console, switch 2, and I pinged 201.68.109.97. What would happen? See who's following along here. If I go on the console, switch 2, what's the and I don't have it anywhere else in my routing table, I'm going to match it and tell it to go wherever I put, whatever address I put here next. All zeros is an all matching route. Doesn't care what the destination, should start giving out like extra credit in this class. Oh, one class. Go. 201.68.109.97. That's my next hop. So if I don't have any other entry in my routing table, I'm going to send the packet there. Now you have to make an assumption at this point that that ISP router is set up, it's ready to go, it understands the hierarchy of the internet. Basically you're just passing the packet along. Tell it what process ID it is. So if you look on your topology, what's my process ID? 100. Good job. 100. Then I have to tell R1 what network or networks are going to be advertised via OSPF. And there's only one network that's going to be advertised, and that's that /29 network. I'm not going to advertise the other network, the /30, because guess what? It's not, the ISP router is not participating in OSPF. That's why I put that default route there. So I'm going to type the network command, the network address, not the IP address that I put on R1, the network address, which is 201.68.109.128. The network address, very important. I will get emails from 20 students. I can't put my network in OSPF. What IP address are you putting on R1? 201.68.109.129. Well, it's the wrong IP address. You want the network address, not the host address of your router. You do a space and a question mark here. It's then going to ask you for your OSPF wildcard bits, your wildcard mask. Just like your access list is going to be an inverse of the subnet mask. So, we can do really quick binary math in here. What is the wildcard mask of a /29? Quick little hint, 255 minus 248. So, there you go. And then you have to tell it what area it's participating in. So for this network, for R1, R2, and R3, it's all in area 0. That's for the diagram. Area 0 is commonly called your backbone area. All right, so that's all I have to do on R1 for now. I'm going to go in and R2 and R3. I'm going to do R3 first, actually. You're gonna get a syslog message saying that a neighbor relationship has now been established between R3 and R1. That's what that says. Okay? So now they've made an adjacency and they're sharing routing codes. Okay? But only routing tables of networks that we've included in OSPF. So there's one other network that's participating in OSPF off of R3, and that's the 172.21.0.0 network. So we need to add that network in as well. The only difference is it's not in area 0, it's in area 1. So it's net or network 172.21.0.0. Wildcard mask for a /24, pretty easy here. 0.0.0. What? 255. And it's in area 1. Okay? Once I do that, I'm going to do a quick right in there. If I go back to R1, and I do a show IP route, looky there. I have now learned about the 172.21 network via OSPF. That's an O right there. Okay? All right, let's go to R2 and do the same thing. All right, so we'll start up OSPF, router OSPF 100, network 201.68.109.128.0.0.0.7, area 0. My adjacency now, I get two adjacencies because I already have two routers that are set up in OSPF. Router 1 and router 3. Okay, so now I have that adjacency. Alright? Now, per the diagram, I also have to set up another routing protocol on R2, EIGRP with autonomous system number 25. Autonomous system number and a process ID are kind of synonymous. They kind of mean the same thing. At least at this level, they mean the same thing. So, I'm going to global configuration mode, and this time I'm going to type in router instead of OSPF. I'm going to type in EIGRP, the autonomous system number, which is 25 for the diagram. My prompt changes to router configuration mode, and I'm going to put in the network command for the 192.168 network. 192.168.50.0. It asks for wildcard bits as well. So it's a Class C network, just like over on what we did in OSPF for Area 1 and R3, 0.0.0.255. I don't have to put an area there. ERGRP doesn't work on an area basis. It's like all one big happy network. Okay? So I say enter. One sec. So I do a show run, you see my interfaces, you see that I have EIGRP running and OSPF running. Yes, what was your question?
What exactly does the area 1 and area 0 do?
What it does is it's network segmentation for OSPF. OSPF, open shortest path first, makes network calculations based on how the hierarchy of the overall network is defined. So it will send what we call link state advertising. Going back to R1 now, R2, R3, it doesn't matter. So now I do a show IP route. Oh, wait a second, nothing's changed. Where's my 192 network?
Is it because R1 isn't participating in EIGRP AS25?
Well, yeah, but it's participating in OSPF. How can it participate in both? Okay, here's the thing. Different routing protocols will not share routing information unless you tell them to. Okay, they basically don't play nice with each other. Alright? You do this based on a process called redistribution. Redistribution, write that down, redistribution. You are going to redistribute EIGRP and everything that is learned from EIGRP into OSPF. All right? One sec, Alex. I think I'm going to answer your question. I know what you're going to ask as a reminder you do that. Go back to my topology here. Okay, so on R2, I have to tell R2 to share this EIGRP network into OSPF. Okay? You come across this a lot of times when you guys have the pleasure of ever going through a merger. Banks do it all the time. Banks do it all the time. Large companies swallow up smaller companies. This stuff has to happen. Okay? Company A decided that they were going to go with the HP architecture or a Juniper architecture, and company B was all Cisco. Okay? All right? Apples, oranges. Now, I do not redistribute OSPF into EIGRP in this situation because this is the end of the network. If I had other routers, other network segments, more EIGRP, I would do that. But since this is the end of the network, I don't have to in this situation. Did I answer your question?
No.
Okay. Darn. What's your question?
Well, kind of along the same lines, but I was wondering if the static routes get absorbed.
What I want to do in R2 is I want to go back into the OSPF process. Router OSPF 100 and use the redistribute command. Redistribute and tell it what protocol I am redistributing into OSPF. Now remember, I'm in the OSPF process. I'm going to redistribute EIGRP inside the OSPF process. So the command is redistribute EIGRP, the process ID of, the autonomous system number of EIGRP. All right, and very important here, after that I want to use the keyword subnets. Because if I've done any, in this case, it's not a problem. If you don't do it, it's still going to work because the 192.168.50 network is along classful boundaries. It is a Class C, classic Class C network. But in case I have any other networks in the future, and it's a /29, a /20, I want it to take and look at subnet information for its route advertisement. So I'm going to type in subnets here. That's just a best practice. If you don't do that, you're not going to lose any points because guess what? It's still going to work. All right, but it's just a best practice to do that. All right, now that I've done that, if I go back to R1, R3, and I do that show IP route again, lo and behold, I now see my 192.168 network. Okay? Let's look at one thing here on R3 to answer Alex's question, because Alex posed a very good question. Right? So, I see my local network, I now see the 192.168 network, but I don't see that default network to get to the internet. I don't see a default network to get to the internet. So if I had a workstation on my switch that went to Google, and Google's on like 114.27, I don't know. Something that's not on my network. Once it hit the routing table of R3, that packet's gonna get discarded, because there's no route for it. Everybody understand? Everybody agree? Everybody conceptualize that? Okay, it'll go to the switch. Switch has a default gateway. It's just acting as a layer 2 device. It says, oh, okay, pass it up to the router. It's now layer 3. The router gets that IP packet, looks at the destination field of the IP packet, sees that, all right, and then queries its routing table. If it does not have a match, it drops the packet. So we've got to get that default route from R1, where we statically put it in there, and distribute that to R2 and R3. Now here's the confusing part. All right, so we just went through the whole redistribute stuff with EIGRP into OSPF. So you would logically think that, oh, I just got to go into OSPF and do like redistribute static because it's a static default route, right? Okay. Because it is a default route, it is a special kind of route. All right? And OSPF looks at that differently than all other static routes. So we have to go into OSPF and do a special command called default-information space originate. Write that down. Don't forget it. Default-information space originate. So in R1, we're going to go back into OSPF. Default-information originate. Okay? Hit enter. Now if I go back to R2 or R3, I do a show IP route, bada bing, bada bang, I now see that default route. Okay, last step, so you don't have to go through this entire evolution in one sitting. Write them everything, RWR everything, your routers, your switches, R1, they do R3. ISP router, switch. Oh, I'm gonna switch up. Switch 2. So once I write memory on everything, I can then go to File, Save Project. Now I've already created the name of the project, so I don't have to do Save Project As, I just do Save Project, and I'll save it. And from here, I just click the big old stop button. All right. All your consoles, they're still going to be there, and you close those out.